short animation explaining the logic and working of the project is shown. We are using three sensors. Firstly, a flex sensor, which are variable resistors whose resistance change while bending them. The second sensor is an accelerometer, which gives precise position of the tilt with respect to ground as equivalent voltage. The last of all is a joystick, which is used for the navigation of the robot. All of these are used to capture the user's motion and control the robot. The three sensors give analog voltages corresponding to their position. These analog signals are then fed to a 16x1 mux whose output is sent to a filter. The filter eliminates the high-frequency noise components of the sensor output. These analog values are then converted to corresponding 8-bit digital values as and when they're given as input to MSP 430. The ADC value is concatenated with select inputs of mux and header file, which is used for the verification of the packet. This helps in identifying the data that corresponds to each channel. The data is encrypted using a security key provided by MSP 430, thereby ensuring secure transmission. Consequently, the data is transmitted over the network using serial transmission. The transmission takes place from the server computer using Universal Asynchronous Receiver Transfer, or otherwise UART protocol. The Windows Server 2008 OS used has DHCP server implemented on it, due to which single user multiple robot control systems is realized. TCP IP transmission can be changed to UDP transmission on will. The data can be transmitted to and received from the internet once verification of the client's MAC address is completed. Then the server issues IP address, after which the data packet is routed to the client. At the receiving end, a RF module is connected using RS-232 jack. The RF transmitter takes the values and transmits wirelessly. The receiver RF transmitter transmits the data to ARM Cortex-M3 using wired UART. The controller used is the 32-bit RISC performance using ARM Cortex-M3 architecture, having 256 KB single-cycle flash programmable using Code Composer Studio. In the ARM Cortex processor, the encrypted data is received, which is then checked with a secret key. Once the secret key is identified as the one sent from the transmitter side, the packet is verified. Then the original 2 bytes, ADC data and the address for the data are decrypted. Using the address, the data is mapped to the corresponding PWMs that are available. Once the PWM is matched, the data is processed in the particular pulse width modulation. Using the address, the data is mapped to the corresponding PWM. A PWM proportional to the data is generated. The PWM accurately positions the servo motors used for actuating arm of the robot. The project makes use of various Texas products, including a transceiver, a controller, a processor, and 7 analog ICs. We have also designed PCBs for compact connections at the user as well as the robot side. This is our user setup. The flex sensors are mounted in both the fingers and on the elbows, which help in the movement of both. 3-axis accelerometers are strapped to the user, due to which the rotation and elevation of the hand is realized. A joystick is made use of for the navigation of the robot. All these sensors are connected to the PCB board, which is powered using a bridge rectifier. The board contains a 16x1 mux and a low-pass filter. The board is connected to MSP 430 G2231. This in turn is connected to the server computer. In the server computer, TCP/COM is used for transmission of serial data to the internet. At first, the COM port of MSP 430 is selected and then the corresponding baud rate. As for the next step, we need to specify the mode in which the computer would work, either as a server or a client. Finally, the corresponding IP address is selected. Port 1000 of the computer is used for the entire transmission. Serial player is used to record the COM port values and store it in the hard disk. There is an option to send the recorded data either once or multiple times in loop so that it's aptly implemented in automation. It is most made use of in the case of mass production, wherein it is hectic for the user to program perfectly and also where the task executed by the robot is to be modified. We have overcome those difficulties by easily incorporating the user's action to the robot. The server computer is connected to the client computer through the network. The client computer receives the data and transmits it back to the RF module through RS-232 jack. The receiver RF in the robot side receives the data and sends the same through a PCB board to the arm. The PCB board is powered using various voltage regulators such as TL783, UA7805 and UA7806. The one shown in the arm board, LM3S8962, which gives actuating signals to the motors. These are high torque based motors which is powered using a MOSFET whose gate signals are given by the arm through CMOS switches. The front camera of a cell phone is used as the robotic eye so that the user can keep track of the robot's environment using video calling option. The bot is totally built using 11 servers giving it 11 degrees of freedom. The video shows all the axes through which the servo can move. As you can see, as the user moves his elbow through an angle, the robot follows almost instantly. As the user rotates his wrist, the bot follows with great precision. The robot is also provided with this gripper which closes as the user closes his fingers. The gripper fabricated is efficient enough to hold as heavy as 10 kg. The various degrees of freedom provided to the bot allows it to handle any object everywhere within its radius. The robot is fabricated in such a way that it can carry itself even in a rough terrain because it's powered by a heavy torque DC motor. As you can see, our robot is self-powered and can be controlled wirelessly, thus making it to be controlled even in remote places. Our bot has a front-wheel drive and all of our peripheral boards and sensors are embedded well inside our robot, which makes our robot to sustain even heavy shocks. Interconnectory boards made reduce the number of conductors and makes the connections look in an organized manner. Most of the ICs used are TI made, hence there is no concern for the availability of the same in the market. Here is another demonstration where the robot is used to handle hazardous chemical reactions. Here, the user controls the robot using RF and with the help of a robotic eye. The user accesses the robot with ease using the sensors and a perfect view of the environment. This particular function of the robot was intended to prevent life-risking situations of many who have no option but to work in dangerous environments. Our robot can also be used to handle high-voltage appliances as a robot arm is built with acrylic sheet, which is by far the perfect insulator.